I'm not recording. Hey, everybody. Welcome to Haystack. This week we have Sujit from Elsevier. He's going to be talking about question answering a search, the Anserini pipeline, and other stories. I'm really looking forward to this talk. Really looking forward to seeing Anserini in action. I've never had a peek of it before, but I've heard quite a bit about it. So with that, I'm going to stop the share and Sujit, let you take it over. Thank you.
You can see this right now, right?
Yep, it looks good.
Cool. All right. So, okay, thanks, Max, and thank you all for coming. I'm going to start this. Okay. So today I'm going to talk about some of my work with question answering, specifically the BERTSerini system, of which the Anserini system is basically a part of. Before we start, a little bit about me. I'm going to keep it brief. My name is Sujit Pal. I work at Elsevier Labs. My current role is that of an NLP data scientist and largely self-taught. Previous job, I used to be in search, more traditional kind of search, initially with Lucene and Solar. Nowadays, it's mostly at the intersection of machine learning and deep learning as well as search. So we started looking at question answering at sometime in early 2019 when the BERTSerini paper had just come out. And quite a few of us were actually pretty excited about it. Here was something that had the promise of, making question answering over search kind of a reality, right? So the agenda today is basically I'm going to cover a bit of an overview on question answering, just to get some sort of shared understanding. I apologize if you know all this already. I will try to keep it brief. And then I will describe our BERTSerini setup. We were trying to build a clinical question and answering system. BERTSerini had, at that time, BERTSerini had state-of-the-art results, and our results were comparable, as you will see later. But we thought we could improve on what we had. So we spent some time looking at alternatives, basically around passage reranking, which, spoiler alert, unfortunately, were not successful. So we ended up going with the Anserini pipeline as is, So in any case, I will describe the things we attempted. I know one paper that we learned about later that used a similar kind of approach, again, passage reranking, and they got significant boost in mean average precision, using mean average precision against BERTSerini. So types of QA systems, as I mentioned. So when I say types of QA systems, I'm not going to cover all of them. Many QA systems are backed by rules engines or knowledge graphs. Since we are all search people here, I'll focus on the QA systems that kind of look like search. In the sense that you type a query in and it goes out and looks up some corpus and give you back results. So more like a search experience, right? So the pipelines that provide that kind of thing. So the first kind is the traditional, right? I mean, it's so traditional, it's covered in Jurafsky and Martin. And it looks a bit like the flowchart on the right, right? It's so hang on a bit. Okay. So other examples of these systems are IBM Watson and Yoda QA, but those are of course much more complicated. In general, the pipeline is like this. I mean, the query is deconstructed using some kind of NLP techniques, maybe extracting nouns or noun phrases or named entities. The query type is determined using some sort of classifier. Is this a why or a what or a how kind of question, right? The results are retrieved from the search index using the rewritten query. Then the results are re-ranked based on various features, such as how many words or bigrams or phrases or named entities, from the question are in the passage. Similar, it's very similar to LTR, the kind of features that you would use. And then the answers are extracted from the highly ranked passages using some kind of rules or patterns. The second major type is the two-step retriever reader system. The BERTSerini system is an example of this type. The other popular example is Dr. QA. And Dr. QA is kind of iconic because that is the first of this genre of systems, that is almost the first one. So everybody kind of looks at that. So here, the basic idea is that you have a retriever component that is unsupervised. It depends on a scoring system like TF, IDF, or BM25 to retrieve good passages, candidate passages given a query. In case of Dr. QA, the retrieval component is RDBMS backed with a TF, IDF ranker. And in case of BERTSerini, it's the retriever component is a Lucene index. In case of BERTSerini, the retrieved results are re-ranked using a specific re-ranking step. And this whole pipeline is actually handled by the Anserini component. In case of Dr. QA, there is no re-ranking. It actually depends more on the reader component, which is slightly different in this case. In the case of Anserini, our reader component is basically just a BERT, trained BERT reading comprehension model, which takes a question passage pair and then predicts an answer span from the passage. So, and a score. In case of Dr. QA, each retrieved result is passed into a pair of, each passage is sent to a recurrent neural network, and the question is also sent to that. And the embedding that you get out of that is then sent to a pair of shallow networks, which predict the start and end of the answer span. And of course, the highest scoring spans are reported as the answer. The third type is the dense retriever and reader. Examples are Orca and Realm. Realm is actually, it's making waves now, very recently. Here, both the retriever and the reader are trained end-to-end. There is a slight kink here. In the case, you need to pre-train the retriever. So in case of Orca, they have something called an inverse close task, which is unsupervised. So you take random passages and then you extract sentences from it. And the sentences are basically proxies for the question, right? And the idea is to train a system that, given the question, would try to predict the enclosing paragraph, right? So that is a pre-training step, though. So once pre-trained, the retriever and reader are then trained end-to-end using question as answer only, right? No passages. The passage is only for the pre-training step. So in any case, Realm is kind of similar, except that the pre-training step is basically a language model machine. It's the masked language modeling task that BERT and BERT-like systems typically do. But that's the only difference. Otherwise, the idea is that the entire system is is dense and it's trained end-to-end. Okay. The final one that I'll look at are the language modeling, the language model-based systems. Here we have dispensed with the corpus entirely and the indexing, retrieving, and everything. Everything is based on a trained model, which contains world knowledge, right? Examples are T5, GPT-2, and GPT-3. And the idea is that the language model stores the world knowledge implicitly. The reader is basically a fine-tuned question answering system. And that's pretty much it. The downside, of course, is that you need to train the entire thing every time. So in any case, we selected BERTSerini, which is an example of the second type, the two-step retriever reader system. So this is my interpretation of what the BERTSerini system looks like. It's actually a little flashier than the one in the paper. But essentially, the input is from Wikipedia, right? So Wikipedia paragraphs were, they were indexed into a Lucene index. And the Lucene index was part of the pipeline. And then this would, when a question comes in, it would, call Anserini and basically come out with a set of candidate passages. And then these candidate passages would be passed into a pre-trained BERT reader, reading comprehension model, which is fine-tuned for question answering using Squad. And this would find answer spans. And so the combination of the segment score from Lucene for the selected candidate passage and the span score for the answer would be interpolated to create the final score, and the answers would be ranked by score, and the best answer or the best set of answers provided. Right. Well, BERTSerini at that point looked very attractive to us, and I want to kind of cover why. Right. So first, question answering was something we were looking at already, though at that time we were thinking more of a traditional pipeline. And second, at that time, BERT had become massively popular in the NLP world and was breaking all kinds of records, including question answering. And the reader was BERT-based, so we had high hopes for that. Third, we also looked at the third type where you had this vector-based search. But at that time, vector-based search was pretty new. And given our large data sets, neural retrievers, we didn't think would actually be very practical. And at the same time, we figured that the paper was pretty decent, and if you could replicate the paper, then we could cut out all the the data collection and feature engineering stuff that we were thinking of doing originally. So BERTSerini kind of hit a kind of a sweet spot for us, and that's one of the reasons why we actually looked at it, right? So, oh, did I go back? Sorry. Okay. Oh no. Okay. So, so again, this is where we changed it. Oh, wait, what happened here? Sorry. Okay. Okay. So here are the scores, right? So on the paper reported state of the art, as you can see, and so it actually beat the the big the benchmark to beat was Dr. QA, and there were others that have beaten it at with smaller margins, but BERTSerini kind of beat it with a pretty big margin, as you can see, like 11 points. So one of the first questions that we were asking is that how would it translate into our system, right? We had different data. We're not doing Wikipedia. How would it work for us, right? So that's basically what we ended up with. So we replaced various parts. The pipeline as it was mostly the same, but we replaced various parts of it. So first off, we replaced Wikipedia with paragraphs from Science Direct. That is one of our data sets. Later on, we replaced it with Clinical Key because we wanted to present it to our health group internally. And so that was one. Then we replaced the leucine index with a solar index, because Anserini is basically a batch-oriented system, right? It was meant for recreating benchmarks for Trek. So it's basically a bunch of scripts, right, that uses leucine under the covers. We wanted to have more of an interactive kind of system where we could present to people, where they would enter questions and get back an answer. So we wanted to do a proof of concept which included like a web interface. So for that, and also we were doing it, we are creating it on AWS. So, having it on Leucine would have meant that we could look only using Luke, and we didn't know how to use Luke over SSH. And with Solar, you have a web interface, so you can just look at it over HTTP. So, so the Solar decision actually necessitated Solar plugin, which we created, and basically, it was a lot of copy-pasted code from Anserini, right? On the reader side, we actually got better results with Cybert trained, fine-tuned with Squad 1.1, rather than the BERT base on case that it came with, the BERTSerini pipeline came with. Basically, these were the two big changes that we did. There were also other changes we made to the reader. So I already talked about this. I'm going to skip that. The Anserini retriever changes, basically, so we basically created our own Anserini plugin, and we also open sourced it. Code, of course, it's all copy pasted, so it won't win any prizes for good software engineering practice, unfortunately. But we are hoping that somebody might find it useful enough to consider making it more acceptable, more maintainable. Essentially, the idea is that I would have preferred to delegate to Anserini rather than basically copy paste code from it, right? So that's the major issue there. But because of shortage of time and, I just had to get something running. So, it works. It works, but it won't, anytime Anserini changes, the changes won't obviously be reflected back. So this is on the right side, you see the README for my Anserini plugin. And there is a URL up here. And I'll go a little bit of, go into a little bit of depth with the Anserini, the Anserini, a little bit of depth on how it basically is used. So it's like any other Solr plugin. It takes an HTTP GET request. And in that, you pass the query, the question, the similarity. So for similarity, we implemented, we wrote the paragraphs using different kinds of similarity implementations, right? One was QL, which is Dirichlet something or other, and BM25 was BM25. And then, so that's the similarity. The Q type is how the query is going to be rewritten, right? So for the query rewriting, we had Anserini gave us two methods. One was bag of words, which is what it sounds like. It's basically an OR query of all the terms. And the other one was SDM, sequential dependency model, which is a little more elaborate. It uses bigrams and also pairs of words in the query, which are not close to each other, and it weights them differently. It's a little more complex, but it's, again, it wasn't like really very complicated. In addition, we also added edismax and raw. So edismax was based on when we're reading about Dr. QA, and they have an Elasticsearch backend as well now. And the query they used was basically, I think it was most fields. It's an Elasticsearch thing. Oh, multi-match and most fields. That's what they used. And so edismax seemed to be kind of similar on the Solr side. So we did a edismax. Also, we have a raw where you can just pipe in whatever losing query you want, and it'll just use it. And the R type is for result re-ranking. So once you get back the results from the rewritten query, you want to re-rank the query so that, using some kind of algorithm. So again, Anserini gave us RM3 and axiomatic. RM3 is relevance model 3. So essentially, it extracts the high frequency terms from the result and reweights them. So it reorders the results, so using these high frequency terms. Axiomatic does something similar, except it also considers results from outside the query set that it got. And in any case, axiomatic, I faithfully reproduced what Anserini did. But in practice, we found axiomatic did not perform as well. So mostly we stuck to RM3. For the later part of the experiments where we were doing passage re-ranking, we also added an external hook into this pipeline, so it could actually go and look up an API. Right? It could delegate to an external re-rank service, which is what we use for the the re-ranking piece. And the output is an HTTP response, like you see here. The top piece is the params shows you what kind of parameters you would use. So essentially, it's like one pipeline with different alternatives at each step, so you can choose. And then this bit is what the rewritten query looks like. So if you think, so this is the input, right? Q is does atenolol treat atrial flutter, and the query A is how the bag of words query rewrote the query internally, and query B is how the re-ranking query uses the frequencies to create a weighted query again, right? And this is mainly for debugging, but I thought it might be interesting for you guys to see, right? So then we go off to the experiments. We know enough about our homegrown BERTSerini pipeline. So the experimental, the basic setup that we had is mostly driven by recommendations in the paper. For example, using paragraphs, right? So the BERTSerini paper showed results, and their paragraph results were much better than the article results. So we decided not to use article results at all. We just went for the paragraph results. The other thing that this is not really, we didn't just stick to this. We tried other variations as well, the BM25 bag of words and the RM3 pipeline. But in general, we found that this pipeline worked the best for us for, across all our results. So, again, what we did, our findings were in line with what the paper said as well. Also for the scoring, as I told you, it's a linear interpolation of segment and span score, where so it's, alpha is the interpolation constant, and they chose 0.5, and we did the same, right? So it's equally, the segment score and the span score have equal weight in the final score. One place where we diverged from the paper was that we insisted on using k equals 1. So all the results that Anserini or BERTSerini gave us was at k equals 100, k equals 30, and so on, where they're looking at the results, the top 100 results of the top 30 answers returned by the Anserini, and computing their F1 scores and the EM scores. We'll come to that soon. Based on those, so it's basically it's EM at k, where k is 30 or 100 or whatever. We wanted to basically use it as a something that where we would try to get the top answer from this, right? So we insisted on a k equals 1, and so our results are a little much lower than what they have, but again comparable to what we would have at k equals 1. For the metrics, we used exact match, that is EM, and F1 score. So for exact match, anytime the pipeline predicts an answer that is identical to the label after lower casing and punctuation removal, EM score is incremented, right? And for the F1 score, again, after lower casing and punctuation, we take the predicted answer, and then we compute the overlap between the predicted and the label answer, right? And that is what we call our true positive. And then for precision, we divide our true positive by the number of tokens in the predicted answer, in the predictions, and recall as the number of true positive terms divided by the number of terms in the label, right? So, and then we compute the F1 as the harmonic mean, right? So that's a little bit about that. And I think that's okay. Yeah, so everything that we did was top k, as we said. So so the first experiment that we did after we set up this pipeline was basically do a manual check of the answers, right? So from our e-learning part of the house, we have a data set of a question bank for nursing, right? Which is kind of similar to clinical questions, but not really, but it's close, right? So there are about 300,000-ish questions there, and they're all ranked by something called a Bloom's taxonomy. So Bloom's taxonomy gives you a measure of the difficulty of the question. Remembering is the lowest, and it basically means that you have read some material and then you're asked some questions that that is designed to check whether you have retained the material, right? So there's kind of similar to the factoid questions that Squad is designed to address. So that's what we took. We took 100 questions from there, classified as remembering. And then we ran these questions through this pipeline, and we manually inspected each answer. So as you can, here is an answer on the side. The answers are reasonable. And in this case, the answer is correct as well. And the passage makes sense. However, one thing that has struck me repeatedly is that it's not easy to find a pattern, why it chose the answer that it did. So there is that element of magic in this, obviously, right? And the bottom piece is the provenance, where, what chapter it came from, what book it came from, and so forth. Here are some more good results. And as you can see, again, the answers are correct. And, the arguments are also, it makes sense, right? But then there are also some bad results, right? So in the first case, as you can see, the answer is quite meaningless, right? I mean, it doesn't answer the question, and the answer makes no sense, right? The second case, the answer is correct, but it's probably not the best answer, right? So if you think of this, I mean, this is kind of a finding that that method trick set also treats, right? Whereas the question is basically, what conditions? So I would have expected a better answer. So again, so there are issues here, right? I mean, it's not 100% that it can get. So, so parallel to this, while I was doing this, some of my colleagues were actually working with the BERT flavors on the reader side to see if they could do better on the squad evaluation data set. And this is without the backend, right? Without the retriever. This is with canned squad, passages. So here are some of our results. As you can see, the first line is the one that BERTSerini came with, right? The BERT based uncased. We actually got better results from with SciBERT. SciBERT is trained on PubMed, so it actually, it makes sense why it would give better results for clinical stuff. Actually, not clinical stuff. This is on squad dataset itself. Sorry, but it still gave us better results. And the bottom piece, the bottom line is the human level. I got this from the squad 2.0 leaderboard, and at that time, BERT was not there yet. Today, of course, the numbers are in the 95, 97 range, and more recent question answering systems have surpassed even the EM and F1 scores. But at that point, what we got was slightly, around state of the art, right? So that brings us to the next step, right? Once we have these pieces working in isolation and we have done this manual experiment, results look kind of encouraging. So we wanted to measure, right? So what does, so with Squad is a typical reading comprehension data set, right? Is reading comprehension data set. And the task that the BERT question answering module does is basically reading comprehension. That is, you give it a question and a passage, right? And then it's a system that predicts the answer span from within the passage, right? So for that, you need the question, passage, and the answer. Whereas with our nursing content, we had the question and the answer, no passages, right? So it wasn't, we could not use it as is, right? So kind of at that point, there was another one of our colleagues there who was also working on question generation, right? So with his help and with some manual effort, we were able to create around 250 triples using selected passages and then generating questions from them and culling the questions as to make it more of a factoid type questions. And then we backfilled the 250 with the 60 that we got from our previous experiment. And we now have approximately 300 question, passage, answer triples. And so that was the basis for all of our tests going forward. So once we have, so once we had our MedSquad data set, we then used it to re-evaluate our, the baseline that was without the retriever. So essentially what we are doing, we are running the squad evaluation, but with MedSquad instead of the squad evaluation data set, right? So our MedSquad data set is being used. And immediately we noticed a drop of about, I think 15 points, yes, 15 points for EM and 10 points on F1. Again, not totally surprising because Squad, so the BERT system is trained on Wikipedia, on general knowledge, not on medical stuff. So, and then we, plugged in the Anserini piece, right? And then we saw even bigger drop from that point down 40 points, right? So initially the drop was quite concerning, and the first thing we thought of was that we are doing something wrong. So we checked and we were not, right? So then we started thinking, what could be the reason? And then one of the hypotheses was that it's not getting the answer spans it needs. And so, and that turned out to be true. And so we started looking at, so basically Anserini, we started looking at Anserini, right? So now there are two steps in Anserini. The first step is bag of words in our case, and that is the most permissive we can get, like, it's terms OR together. So we started looking at the passage reranking as a possible culprit. And, we didn't know of it at the time, but Noguera and Cho here, they had also started working on passage reranking. And they actually got better results. They got a boost, on top of BERTSerini by around 10 points on, I think, on mean average precision. But we didn't. So, but just letting you know. So the first step, so we did various things, and each of these experiments are backed by many, many, permutations. What you're seeing here is the best one that we got out of that set of experiments. So the first thing we did was we used BERT as a service to wrap a BERT-based uncase model that returns embeddings from its last layer. And so essentially what you're doing is you're sending the query, producing an embedding using the BERT as a service. Then you're sending the passage text and also getting an embedding using BERT as a service. And then, we are using only 10 passages at this point. We then re-rank, we do cosine similarity. Sorry, we did 50 records, sorry. So we do cosine similarity between the query vector and these 50 passages, and we give you back the passage re-ranked by similarity descending, right? The second one is query sentence relevance re-ranking. And essentially this was, it's a BERT-based classifier that returns 0 if the sentence, the two sentences. So we are looking at the query as a single sentence, and the passage is each passage is a group of sentences, right? So with the question on each sentence, we would try to classify it as being this sentence pair is relevant versus not relevant. And then we would, so essentially a passage would be relevant if the mean of the scores that we got was, whatever it got was the score for relevance, right? We trained it on the Trek microblog dataset. And, this is the specs that we used. And it wasn't as good as Anserini at this point, right? I mean, the EM and F1 scores are not as good. It's better than the BERT as a service though. So our third attempt was a BERT-based regression model that took the passage and the question, so the entire passage and the question, and it predicted a number between 0 and 1. If it was 1, it's relevant. If it's 0, it's not. And we looked at the the breakup of the predictions against the test set, and as you can see, there is quite good separation. Unfortunately, when you actually try to use it for question answering, the results are not as good, right? And then finally, we used the Siamese BERT re-ranker. We didn't train the model ourselves. This is the pre-trained model that we got from UKP lab. And again, this is kind of similar to our second approach, where we did the sentence, the sentence classification, each sentence pair classification. So here they're doing exactly the same thing. The passage score is, the final passage score is either the mean or the maximum similarity between the questions and all sentences in passage, and the passage is ranked by score. So we got good results in with the maximum similarity, right? And in retrospect, I think that makes sense, because if you think of a passage, it is a sentence in the passage that is a good answer to the question, right? Not the mean of all. So that we should have kind of thought about that in there. So the results are very close to what Anserini provides, right? The results here. However, Anserini still beats it. So here are the results altogether. As you can see, among the things that we did, the Anserini baseline actually has the best results. And however, if you look at, even though 38.6 is much higher than 23.02, if you look, k equals 100 here, and as k falls, so does the EM number. And at here article k equals 5, but if you had paragraph, we are doing paragraph k equals 1. So based on that, I think that maybe, we are kind of there. I mean, it's not, we have kind of reached the limits of what the system can give us, right? So here are the conclusions. We couldn't beat Anserini with any of our passage rankers. Our results are comparable though to those reported in the paper, at least based on the interpolation that I'm doing here. Response time though is unacceptably slow because of the slow reader. We could have still thought of working on that using model distillation or moving it off to a GPU based server and so forth. But the quality of the answer snippet is also not acceptable all the time. So it's kind of too risky for production use. So at that, at this point, we kind of shelved the whole thing. And then, COVID-19 came up and we moved on to different things. But I think we'll come back to it now that we have more, progress in the field in general. And, we'll go back to it once the, the pandemic issues around the pandemic are less prevalent. So that's pretty much it. Yes, that is it. So I can take questions. Thank you for listening. And yeah.
Thank you so much, Sujit. That was awesome. There's a lot of stuff. I hope everybody here was familiar with BERT before they came to this talk. So feel free to drop your questions in the chat while you're writing your questions. As the host, I get the default honor of asking the first question while everybody else is thinking about theirs. We've played around with BERT a lot. We've never used it in, we've never used BERTSerini, but we've done a lot of manual stuff to try to get BERT to do various tasks in relevance ranking and in recommendations. We've never tried it on question answering. But my question for you is, have you looked at using your re-ranker? It seemed maybe a little bit simple. And have you looked at using, for example, maybe LambdaMart or traditional learning to rank with the BERT similarity as a feature along with your BM25 and some other things? Have you considered that at all?
We haven't. So during this whole process, I think we were suffering from tunnel vision a lot. So we were kind of constrained by the BERTSerini architecture. We have to kind of stick to it and so forth. But now that I have had a chance of it's been 6 months, I haven't actually looked at this thing, right? So you kind of think about other possibilities that are good, and so yes, definitely I've thought of LambdaMart is one possibility. Also, as you noted, each of those re-anchors did one feature each, right? They kind of leverage one feature. Maybe we can do better with a multitude of features. The other thing I was thinking of is that I want to look at, and this has been bad on my part, things like Yoda QA, right? Yoda QA is the Watson open source, well, it's not Watson, but it's Watson-like. Yeah, exactly. So, so look at techniques that Yoda QA uses, or even Dr. QA uses, or even ideas from Juravsky and Martin, right? Where these are solid ideas. I mean, we can enhance them. It's not necessary to just stick to bag of words or whatever, right? Just because BERTSerini says it is. So I have been thinking along those lines, that maybe we could, mix traditional with neural, right? And get better results that way.
Yeah, I think a lot of teams are having success when they do that. They're taking this new technology. They're finding that BM25 works so well for a lot of the features, but it's just another boost, another thing to throw into the bag of features that you can use to improve relevance. Question from John Kane: how close is this approach to real Q&A environments for use cases such as massive online courses to help students?
This is more factoid kind of questions. So real Q&A environments would involve more analysis, well, not maybe, very deep analysis, but deeper than this kind of questions address. This is mainly for things like, it's the place, the place I envisioned it as would be like in a search interface where somebody asks a question, right? A factoid question again. And the idea is that if the question was not, if it hit the sweet spot, so we would have a classifier saying that, this question is answerable by a pipeline, right? And then we would, once we see that question, we would send it off to our pipeline, and we get back the top answer, and we place it at the top of our search results. And, regular search results follow, right? So that was the use case that I had in mind for it. So I don't think it's a replacement, to answer your question. I think we're not there yet, at least not us.
Yeah, we're pretty far away from just general intelligence of answering any question. I think that a lot of these tasks are quite narrow at this point. I know that there are other questions. Hopefully people are typing them right now. It's not like a chat application where you can see who's typing.
Actually, let me unshare, so that way, stop share, then I can see the chat application. Here. Okay, I saw John Keynes.
Yeah,
okay.
Or we have a small enough crowd now. We've got 23 people on. Feel free to unmute yourself if you don't want to type. We can have a real conversation. Okay, I'm going to ask another one in that case. So you said you did 100 factoid type questions that you labeled.
Mm-hmm.
How big was your overall data set? And 100 seems quite small, and it probably took you a little while to get that. But
actually, the Med Squad data set that we talked about, that had around 300 questions. Okay. 250 were hand labeled, mm-hmm. and 60 of them came from the first set of questions that we got. So the first set was basically a random set marked as remembering type of questions out of our 300,000 question bank, right? So of those 100, we basically looked at each one, the answers for each one, and we found 60 of them that were decent, that we could present to a search audience, right? And the answer made sense, and even though it wasn't clear how it got the answer, the answer was okay, right? Mm-hmm. And then the other 250, we basically so this my colleague was working on question generation, and question generation also happens to be very noisy, right? At least the ones we are doing. So we identified a bunch of random passages that from our index, the paragraphs, and then we ran our question generation against that. And then we took, we had a human being take out the questions that looked wrong, right? Yeah. So that's how we came to the 250 questions.
That's a good approach. Yeah, I like that. It's easier to take stuff out than force somebody to type things in. You just say go instead of trying to, oh yes, this is the
exactly.
Yeah, it's that's a pretty effective technique for gathering a data set. I like that. Somebody else ask a question. I'm gonna start calling on names.
I think I got a Haystack conference. Hang on, it's on the Slack. I got something.
Oh, you got something on Slack? Oh, we're all over the place.
Threads. What are the first few experiments you would prioritize when you resume work on QA? I think one of the things that, so the question here is from Peter Dixon Moses. From what you see available today, what are the first few experiments you would prioritize when you resume work on QA? One of the things I think I would revisit is the passage reranking again, but this time based on the Cho paper, the Noguera and Cho paper. What they did was using MS Marco dataset, and they are reporting a 10-point increase on BERT's results. And the other thing I would think of is that I've been kind of against the post-processing of answers, but maybe it is something to consider, right? So assuming, that you see people getting better results with k equals, 30 or 100 or whatever, right? So maybe we generate 30 answers and then, use heuristics to basically throw out answers that don't seem plausible, right? So that is another approach. And this is kind of low tech, I guess. I mean, it's not flashy, but that's something I would think of. The other things I've been thinking of is going, more towards basics, like going back to traditional approaches to, create better queries and, try to get the results back. I don't see much problems with BERT itself. And the another thing I actually want to do is the med squad data set, as you noted, is just 300, and it's actually quite small. I have a feeling that it's not very representative either, because if you think of the drop that we saw, the 10-point and the 15-point drop, when we switched out the squad, evaluation data set with this one, and squad evaluation data set, I think, is around 6,000, right? So we have just 300 to go with. We noticed a drop, and I think if we have a bigger data set, we will see a better result as well. So a lot of, different things, are kind of popping up, and, things I'd like to try. So I think, but the very first thing I would do is, redo the passage re-ranking thing using the, specifications from the Cho and Noguera and Cho paper. Yeah. Have you experienced any performance barrier while pre-processing of queries before feeding into Solar Engine? What is the approach for any automated QA? Automated QA. So the automated question answering, right?
Yeah, maybe answer the first question about the performance.
Okay, yeah. So
if you want to clarify your second question, while Sujit is
actually there is I don't think there is a performance barrier while pre-processing of queries. The pre-processing is actually very simple, right? It's basically if you're using what I'm doing is basically lowercasing and tokenizing. That's it, right? And there is nothing there. Actually, I'm not even doing it. Solar is doing it because I'm sending the query in by itself. It has a lowercase tokenizer, and it uses. I think it's basically whatever tokenizer that it uses for splitting into words, and then it's an OR query. Oh, quality analysis. What is the approach for automated quality analysis? That's actually a good question. I don't have a good answer for that. Apart from the standard med squad data set that we are doing, maybe beefing that up and trying to get results from that. Beyond that, I don't see much, by the way, in the way of automated quality analysis.
Just a note on how when K goes down, you get less. It seems to have less accuracy. Let me know if this lines up with your findings. What we found is that BERT and similar models, when they're not fine-tuned on a specific task, if you just take like the out-of-the-box, the BERT based on case, and those types of models, we find that they work really well as an initial recall step, because it's a very fuzzy way to go out and grab a whole bunch of information. So as your K goes down, you're looking for more precision. And at least in my experiment, in my experiments and a couple others in OSC, we're not getting that good precision from those models, and it's not. Our conclusions were we really shouldn't use it for that, unless we're doing something like a later step, like a lambda mark, like a learning to rank step 2 as a re-ranker, just to go out and do this initial recall and give it some more contextual grab for something instead of just like a keyword match. Is that your intuition as well, or what?
I would think it falls. That's true for anything, though, right? I mean, we actually did a set of experiments on this, and where we varied K, and we saw a drop off very similar to what you're saying. Also, I mean, I think it's true for search in general, right? I mean, if you think of precision at K, where K equals 1 versus K equals 5, precision is better, right? I mean, k equals 5 because it has more chance of getting the right one. Right. So in that sense, on the precision side, yes, I mean, it feels very similar to what BERT does. Yeah.
All right, we're starting to lose folks. Our participation is dropping. Sujit, thank you so much for your time. I do hope you have a chance to pick this up again, and maybe you'll give another talk next year with part 2 of hopefully a very, very successful outcome. Maybe this goes to production at some point. Thanks again, everybody, for coming. Again, just a reminder, if you're not on Slack, join Relevancy Slack. Share the videos, join the meetup, build the community. This video will go up on YouTube this afternoon, and you can rewatch if you missed something or share it around. Thanks so much. We'll see you next time.
Thank you.
Bye.